Hi there, my name is Matthew Eades and I'm going to be presenting to you today the second version of the print and apply machine. This machine prints out barcode stickers, peels them off and places it on two sides of a box. This is how the machine works. It picks up the first sticker, places it on the one side of the box, then goes back, picks up the next and goes to the next side. Then a new box will come along a conveyor system and the process will be repeated. The problem statement: to design and build an affordable, efficient and reliable print and apply machine that places a printed barcode sticker on two sides of a box. This machine will be suitable for all types of companies that need accurate labeling, as well as it speeds up the production process. As I said, I'm going to be introducing today the version 2 of the print and apply machine. On the left is the first version that I created in the first term, and today I'm going to show you briefly how I got to that version, as well as how I got to the version 2 and the necessary changes that need to be made. So first of all, on the version 1, I started off doing some sketches after Vainan from Automation Works briefed me on making a print and apply machine. During these sketches, I learned a lot about how the mechanics of this project was going to work, figuring out how the arm was going to rotate around each axis to be able to get to the box. I then moved to SolidWorks, where I created my first model just to try to understand more about the mechanics and how the product was going to work. I then carried on SolidWorks, where I spent a lot of time developing and finalizing the first version of the print and apply machine. I then manufactured all these parts and built the first version. After creating the first version, I can now conclude that the first prototype was very successful in helping me understand how the mechanics of the machine was going to work, as well as understand how the arm was going to move from the printer to both sides of the box with no interference, as well as understand how I'm going to peel the sticker off the sticker backing. Festo has also indicated that this project has the potential to go to the next level if all the small issues regarding the server, power and weight distribution can be resolved. These are the necessary changes that I needed to make to the version 1. The main goal was make this product a lot more industrial by looking at the industrial automation, and this meant making this product a lot stronger and creating it in a way that it will be able to last in the environment. First of all, I needed to look at upgrading the RC servo motors that I used. I'm going to need to look at using a lot more industrial motors, such as the Festo range. These motors will be able to provide a lot more torque as well as accuracy, and will also be able to last in the industry. I then need to investigate the center of gravity of the arm. As in the first prototype, the arm didn't connect at the midpoints, and this meant that the motor needed to produce a lot more torque to get the arm rotating. The pneumatic control system of the sticker placement also needs to be looked at to get that fully operational, as well as I need to look at replacing the Arduino with a more industrial controller. This here is the second version of the print and apply machine, and straight away you can see that it's a lot more industrial with the materials that I've used, such as aluminium. And as you can see, it's just built in a way that it looks like it's going to last a lot longer. And you can see all the small little things I've added to the product to kind of finalize the version 2. I spent lots of time on SolidWorks just figuring out where all the little screws, bearings, springs and all the little components were going to go and how this machine was going to work finally. These are the necessary changes I had made. I redesigned the reel system, and now the system has a spring loader which allows the sticker backing, the excess material, to stay taut while it winds up on the reel. I've also redesigned the center of gravity of this arm to make sure that the arm connects at the midpoints to allow the motors to require less torque, as well as added limit switches in the necessary places to help know when the machine is at its home position, as well as once the stickers hit the box. I wouldn't want the box being knocked over by the arm or anything in the box being broken. So that's why I've added limit switches there. I've also designed and built this in a way that all the parts will be able to be manufactured finally in aluminium, as that is a nice strong and light material that I can use for the arm. A big part of this project was upgrading the electronics and figuring out what industrial components I can use to get this product up and running. The main thing was looking at the Siemens logo PLC. This is the controller I'm going to use to get this product up and running. Then I'm going to be using 3 of the Festo motor drivers, 2 smaller Festo stepper motors, as well as 1 larger stepper motor, as the one motion required a bit more torque. Then I'm going to be looking at the Festo pneumatic solenoid valves, as well as a Festo pneumatic to vacuum generator, which will be able to allow the suction to happen. This is the function diagrams that I created to get the PLC logo up and running. I did this on a program called Soft Comfort, and this basically just allowed me to lay out how my product was going to work, using many time delays and many different functions to get each component up and running at the right times. This here is a bit more of a dulled down version of previous, just kind of explaining how the whole machine works. So as you can see on the top, the print function starts, and this is where the reels and the printer starts printing the sticker, the reels turned on, and the suction plate picks up the first sticker. Then just below that, this function here is all the motors that are required to start working to place the sticker in the first position. Then it goes back to its home position where the second sticker is printed. And these again below are all the motors that are required to get to the second sticker placement before placing the sticker. And once the sticker is placed, it goes back to its home position, and then that's where a new box or pallet can come along the conveyor belt, and the whole process will be repeated again. So what still needs to be done to this product to get it up and running? I'm still awaiting for the Festo motors and drivers to get the electronics up and running. I still need to look at manufacturing the parts, which I'm going to make use of Perspex as a material that will then replicate the aluminium that I'll use as a final material. I need to then get the printer to communicate with the PLC, as well as finalize some of the pneumatic systems that I'm going to be using. The industrial advantages. This project has the potential to be a fully working industrial print and apply machine. This project will help with organization of pallets and boxes in warehouses. It will also be a lot more accurate than the human application, as it will minimize human error. A nice thing about this product is it will easily be able to be scaled up or scaled down, depending on the application. Some of the skills I learned along the way. The biggest skills I learned was being able to program and control the PLC logo. And to do that, I made use of the Soft Comfort program, which allowed me to lay out the function block diagrams. And this program was really nice, as it had a very nice simulation tool, which allowed me to simulate each scenario I built up. Another really big thing I learned this term was the industrial automation of things, changing things from less of a prototype to more of an industrial application and product. For the time management, I rated my time management for this term a 7 out of 10. During the term, I thought I managed my time very well, but there were a few moments where I just felt like I wasn't making any progress. But as soon as I decided on the design project, I was able to make good progress, and yeah, things kind of just started falling into place. It was also very helpful to stick to the given course schedule and just not to fall behind with any work, and that just allows everything to kind of go smoothly throughout the term. This term was very heavily based on a theory, as I did 96 hours on theory, learning the PLC as well as some electrical theory behind it. Then the design project took me roughly 54 hours to design. The tutorial project was 12 hours, where I put together some Festo simulations and got them up and running, as well as PPD, personal professional development, which we spent 17 hours doing this term. For my acknowledgements, I want to thank Vaynant again from Automation Works for presenting this idea to me. I also want to thank Vaynant for believing in me and this project and helping me with the funding and building to create this second version of the print and apply machine. I want to thank Nick for helping me troubleshoot some of the issues and questions I had along the way. I also want to thank Festo for being very helpful when it came to getting the right motors for the right application. They were just very helpful. A phone call away or even a WhatsApp, and they would respond. So I can't thank them enough. And I also want to thank JC for helping me learn more about myself and my personal development. To conclude the version 2 of the print and apply machine, I think it was a huge improvement. I feel I was able to address all the issues I had with the first prototype and make the necessary changes. I think that the version 2 is a much better designed prototype, as it has been designed in a way that it will last in the industrial environment. I'm very excited to get the components from Festo to finally build the second prototype, as I feel like this machine has the potential to be very successful in helping label boxes in the distribution industry. This here is the second version of the print and apply machine. I can't wait to get it built. Thank you guys for listening.